Okay, we're going to carry on with this second part. So in the first part, just scroll back and remind you what we've done. We have loaded in the lat and long, produced a nice world map. We've then downloaded data from the NOAA website and loaded that in as a table. We've converted that into a timetable, which is just a really handy way of storing things in MATLAB. And we've plotted that up. So you can see a big 3-meter storm surge, about a 1-meter tide, and the water level much higher than that. And we know that the maximum water level occurred on the 30th of October at 1 a.m. in the morning. The storm surge was 2.8 meters high. It was greater than 1 meter for 20 hours, greater than 2 meters for 7 hours. Now what's really nice is we're going to now look at some really advanced plotting algorithms, and we're going to load in meteorological data. So we're going to go to ERA 5. This is the ERA 5 website. If you type in ERA 5 single for single layer, and what we're going to do is ERA 5 hourly data on single levels. This is actually a numerical model, but it is assimilated with real data, and you can read more about the data here. Now we're going to go on here, and I've already clicked on this, so it's saved it from last time, but you'll have to register up the top here and log on. Click on reanalysis, click on 10-meter U and V components of wind and mean sea level, and then in fact, let me clear it all. So we'll go for the reanalysis, 10-meter U component, 10-meter wind. By standard, wind is measured 10 meters above the surface of the earth, mean sea level pressure. We're going to scroll down, we're going to go for 2012, October 30th, 1 a.m. Okay, now here we're going to, rather than subtracting the whole region, we're just going to do a sub-region. Just going to move this back over to here, and we are going to go from minus 100 to minus 50. Remember, we're in the west, so it's minus, and we're going to go from 10 south to 60 north. We're going to click on net CDF. I'm just going to check that right. 10, 60, 100, 50. Going to click on net CDF, submit form. Now this should hopefully be quite quick. If you're downloading the whole globe, it could be quite a bit longer, but that file is now ready to download. So we'll click download. Okay, I'm going to go to my downloads. That's the file there. I'm going to move it to my data folder. Remember, always put things nice and separate. At the moment, we haven't got a huge amount of things in there, but as you get busier and busier and put more stuff in, it can get quite confusing. I'm going to click on this and I'm going to call it sandy.nc. Okay. Now let's go back to our code here. Okay, the first thing is we're going to create a variable called file_in_met. So this is our file name, and here we can just put the name of the file, and remember we need to do parse. We go back, so remember we're in code, we go back to practicals, up into data, and then to the file name. So it's back one directory into data, sandy.n. Now this is what's called a netcdf file. So netcdf files are really handy files for storing gridded data, and they're used all around the world. Okay, so what we can do is use this nc display. We can scroll down here and it tells us about the variable. So this has dimensions, so there's 201 rows of longitude, 201 of latitude, only one of time. And here we can see the variables. We've got longitude, latitude, those are both one-dimensional arrays, 201 by 1. Then we have time, then we have U10. You can see this is a two-dimensional array, 201 by 201, V, mean sea level pressure. Okay, now what we're going to do is we're going to load that data in. Now what we can do here is use the nc read. We need to output something. So here I'm going to output long. I'm going to do capital because previously we used lowercase. You put in the file name and then the variable name here. And the first variable I'm going to put is longitude. So we can run that and you can see that has loaded in the longitude. So now I'm going to copy that and change it to lat. Then next variable was latitude, and we're going to load that one in. Okay, now we can copy that again and load in the pressure. This time I'm going to call it P, and if we scroll back up, the file name was MSL, which is, and you can see if you scroll down a bit, it's air pressure at mean sea level. So here we're going to put mean sea level, load that in, and this should load it in a 2x2 degree. I'm going to copy that again, call it U, and this time I'm going to load in U10. I'm going to copy that again and call it V and load in V10. Okay. Just going to check that I did everything right. I hope I did. If not, we'll come back and correct that. Okay. And then finally, if you go back here, you can see the longitude and latitude are just one-dimensional arrays. Just going to close all of these down. So the longitude and latitude are sort of column vectors, but actually we need one, in order to plot it, we need a 201 by 201. So what I'm going to do here is put Y, X, mesh grid, lat and long. And this is going to create for me an X and a Y, which are now the same size as the U and the V. So I can plot those out. Okay, now we're going to plot the data in different ways, but what I'm going to do is I'm going to scroll up, hopefully I'm not making you feel sick and travel sick, and I'm going to copy some code. Always copy code if you can. So I'm going to create a new figure. I'm going to do next tile, and now I'm going to use the function pcolor. If you don't know how pcolor works, you can type help pcolor. Now you can use it just, or if you want, if you click down here, it actually gives you the documentation in a bit more detail. So it produces these kind of nice colored plots that can look really good. Now what we need is we need the X matrices, the Y matrices, and the P, and I'm going to divide P by 100. Now if we plot that, it comes up as a black line, so I need to do shading interp. Okay, and run that. Okay, so that's the data, but what we're going to do is we're going to do a hold on, and now I'm going to scroll up to my map here, and I'm actually going to cut and paste a few things off here, but I'm going to paste this latitude and longitude on there. Okay, so we can plot that lat and long on there. Just give me a second. Okay, hold on. Okay, now we're going to add the global coastline. Okay, and you can see that it's plotted it there. Now the map is stretched. Oh, I'm going to just do this as a 2x2. So I'm going to have 4 figures. Okay, you can see it's looking better now, but it's still a little bit stretched, but we'll come on to that in a minute. Okay, now we can add a X label, longitude degrees, and we can add a Y label. Now you can see I've spelt these wrong, but if I had run this, you can see it would give me an error. And it says unrecognized function. Mostly when it's an unrecognized function, it's because of a spelling mistake. Okay, now I'm going to put the box on. Always looks nice with a box, and I'm going to put my grid on. Okay, and that's looking a lot better now. But what I can do is I can make the axis equal size, so the X and the Y are the same relative size. Okay, now sometimes that messes around with the dimensions, so what I'm going to do is I'm going to set my dimensions here. So I'm going to use the xlim function. Again, if you don't know how to do these, you can just help and look it up, but with the xlim, again, with any function, you have the function name, circular brackets, and here I'm going to go from minus 100, which was my limits of my data, to minus 50, and with the y, I think it was 10 to 60. Okay, we're going to run that. It's looking good, and then we can use the clim function to change the color scale, and also what I am going to do is add a color bar to bring up the color scale. Okay, so there you can see there's the hurricane just south of Manhattan, and a bit later on we'll see what the wind vectors are like. Now if I scroll up here, I can actually put on a color map. I forgot to do this. A color map, you can look up help color map, but there's lots of different color maps, but here I'm going to use the one jet, which changes it to reds to blues. Now what's quite nice is I added this function here where you can select lots of different color maps, and if you uncomment out this code, you can run this and you can mess around with this and you can see all of the different color maps. This is a really nice grey one. I actually like the bone one a bit better. It's a bit brighter. Winter, summer, and have a mess around with this and look at all of the different sort of color maps. That's quite a nice one there. But again, the storm is low pressure, and normally in the northern hemisphere it's anticyclonic winds around that. Okay, now we're going to do the next tile. Okay, and now we're going to do another plot, so I'm actually just going to copy and paste this. But this time, rather than using P color, we're going to use contour, which looks a bit nice. I don't need shading interp now. Again, I'm going to divide by 100 to get to millibars. I'm just going to copy all of this code again, because you can. I'm going to put the X and Wax label on. I'm going to put boxes on. I'm going to set the limits. And again, I'm going to do the color bars, the color scale. Okay, now this time I used contour. Again, you can type help contour if you don't know what's going on. Okay, now you can see we've got a contour map. Now, I think I forgot to plot the coastline on, so let's go on and add the coastline and run that. So you can see now we've got a contour plot looking really nice. So I'm going to cut and paste this. I'm going to go for the third time, but this time I'm going to use the contour F, which is the filled contour, and run that. So you can see once you've copied code, you can actually do things quite fast. So filled contour is like a contour. And if you type help contour F, you can see different settings, and you can see how to plot just certain contours. So you can always have a mess around with that if you like. Then finally, I'm going to copy this again. I'm going to actually take out the coastal lat and long this time. I'm going to take out the axis equal as well. But this time I'm going to do a 3D plot, and it's called surf. And we're just going to run that. Now, when you do the 3D plot, oh yeah, you can see the 3D plot there. I'm going to do shading, shading interp to make it get rid of the grid, or else it just plots. So there, you've got a 3D plot there. And now what I can do is change the view. And with the view, you have two different numbers. You can mess around with these a bit. I'll also show you how to do it manually. There's the view there. In fact, we probably could leave the axis equal on. And again, this is really nice because you can sort of see the hurricane in 3 dimensions. You can see the low winds, the eye of the storm. You can also click on this and you can actually rotate the 3D view yourself. Actually, it probably does look a little bit nicer without the axis on. Run the section again. There you go. So you can click on this. You can look at the view, sort of looking into the hurricane, looking beneath the hurricane. So there you can see actually we've done some really nice advanced plots. We can go back here and change the color scale. Have a look what happens. Let's go for cool. Oh, I've probably got color map in here. I need to take that out to stop it overwriting. hopefully that's changed, yeah. So you can see the different colours there. Let's go for a different one. Let's go for hot. Hot is reds and yellows. Okay, there we go. So you can see really nice hurricane there. So with storm surge, it's the low pressure of the hurricane, but it's also, more importantly, it's the winds. So we want to look at the winds in a minute. Okay, finally, we set all of our axes as 14. Again, I'm going to scroll up rather than writing this from scratch. We did it here. So I'm going to cut and paste that. Run the code again. Always do the exercise as 14 because it looks much nicer. Okay, there you go. So you've done some quite nice advanced figures there. Okay, now we're going to plot winds. So again, I'm going to cut and paste the figure code, make the figure nice and big. And then I'm going to, let's copy one of these. Okay, now we're going to use the quiver function. Again, if you haven't used it before, type help quiver. You can read about it here, but I find it's easier to click on the documentation. So a quiver function is a function with sort of vectors. So we can have a look at the wind. So we're going to do quiver. And here you need the X, Y, U. Here you need 4 inputs and V. We're going to hold on. We don't need a color bar. We don't need a CLIM. So we're going to use all of the same settings as before. And we're going to do a 4x4 plot again. So here are the vectors, but there's so many vectors, it's hard to see what's going on. So let's produce a second plot. And here I'm going to have a variable called int. Let's initially set that as 10 or 5. Now here what I'm going to do is, rather than use just a standard, I'm going to use standard quiver before, but now I'm going to go from row 1 intervals of int, so every 5 to the end, row 1 every column. So I'm going to plot every 5th vector instead of every vector. And we can run that again. And you should see now this produces a much better plot. So actually you can really see the hurricane forming there. And actually if we go up to 10, just plot every 10th one, it's going to be much clearer. But you can have a play around, go from 2 all the way up to 10. And there you can see much better the really strong onshore winds. Okay, now what we're going to do is plot the speed. And to get the speed, we can just use Pythagoras. So it's the square of u, use a dot because it's so you avoid matrix manipulation. And then we're going to square root. So now we've got a variable called SP, which should be 201 by 201. There it is. And that's the wind speed. And again, with wind speed, actually, we can probably use the P color. So let's go up and do the P color code up here. So we'll plot this as our third plot. Okay, now here we can plot a speed. And we're going to vary the color to go from 0 to 25. So let's run that and have a look. As you can see, what's to you? I use contour, not P color, but it doesn't matter. We can just change that to P color. And we need to, if we go to P color, we probably want to add a shading interp to turn off the grid. Okay, there's the wind speed. So you can see the wind speed is much stronger over the sea than over land, but you can see really strong winds near hurricane. Now what would be really nice is to combine the two. So we can have the winds, we can have the wind speed, but also we can use the quiver function to plot the vectors on top of it. Okay, and there you go. And you can change the colors of the vectors if you want. I can't quite remember to do this, but you can look up help. But I think you can just specify, say, white or black on the end. Let's have a look at what white is. The vectors should change to white. Actually, that's probably a bit clearer there. You can see the low pressure and strong winds. Again, you can vary the interval up here to plot more. And finally, If we're going to save this, let's set all the font size and font weight as bold. Okay, so that looks really, really good. So yeah, we've done fairly advanced plotting here, and we can change the color maps to anything we want. Cool. Now I might well have left a color map on here. Oh yeah, that's cool. So you can see the cool color. Now probably what I've done is left a color map on here. Oh, we haven't specified the color map. So we can specify the color map if we wanted in this first one, or else it'll be here. So we can specify color map and the CM, because that's what I get back from this box here. And then that should plot this one as well on the same color map. There you can see it's not, so both of them now are on the same color map. So if I change any of these, it should update both of them. Let's go for summer. Let's have a look at the other one. Summer. Okay, well done. You've done some really advanced plotting. Now, the beauty of this code is once you've saved it, you can now run this for any NOAA site. So what I'd encourage you to go back to the beginning, and rather than downloading Battery Point, download this SOES Point, which is further down the coast in Virginia. Once you've downloaded this data, copy this code, go right up to the top, and now you only really need to vary one thing. You need to vary this, but actually vary the latitude and longitude as well. Run the whole thing, and you should see that everything updates. In Virginia, we should get a smaller storm surge because it's further down the coast, but you can have a look at that as well. And you can look at other sites and see how Hurricane Sandy varied as you're going along the coast. So yeah, well done for completing your first practical. And you can see that actually with only 179 lines of code, in fact it's a lot less because most of these, well no, it's 179 lines of code, you've actually done some quite advanced things, and we'll build on this each week. So use the help menu lots, use Googling, copy and paste code, for example figures when you don't need to do things again. Well done.